Hey guys, welcome back to part 2 of 6.05 function equations. We're going to be picking up right where we left off, still keeping these essential questions in mind. So how can you identify and represent functions? What are some characteristics that you can use to describe functions? So let's go ahead and get started. Function notation. When we graphed equations, the equations for these graphs were represented in slope-intercept form, also known as y equals mx plus b, where we could write this equation, for example, as y equals 5x plus 2. So this was the notation that we've been using that you should be familiar with. We're going to make a slight change to it and call it function notation. So in functions, the equation is written as f of x equals 5x plus 2. The f of x simply represents the y value. Basically, f of x is y, or f of x equals y. So all we're doing is taking this that y equals mx plus b, and replacing it with that notation of f of x. And what that describes, it describes the input and output relationship. So usually functions are represented as an f, so typically it's f of x. If there's more than one function, you might see g of x or h of x. All this still represents is that output, okay? So the function is stating that when one thing is inputted, it will create a specific and unique output, all right? So the function name, this F out here stands for the function name, and this X value is our input. And what we get is that output. When we solve for the input, we get this output, and that's what we're going to be looking at. So before we look at some examples, I want you to think back to Unit 2 when we were evaluating expressions. If I said evaluate the expression when x is equal to 2 and y is equal to -3, what you would have done is replaced all of the y's with -3, and you would have replaced all the x's with +2 and solved. So take a look at this, and that's how we would have solved that. But instead of spending time on that solving, I want to show you what it will look like in functions. So when we evaluate a function, we're actually going to do that same process, that plug in, the solve. But this rule I want you to remember is to evaluate a function, you need to replace its variable with a given number or expression and simplify. Simplify all the way down, okay? Simplify, simplify, simplify. That is very important. So let's go ahead and take a look at example number 1. We're going to follow these steps on the left-hand side. So step 1, determine whether you have the x value or the y value to replace. So if you look, it says find f of 4. So I'm finding this side. But what I'm doing is I'm going to be using step 2, substitute the given number into the function. So it tells me that my x value is 4. So x equals 4. I get that 4 from right there inside those parentheses. So what I'm going to be doing is finding f of 4 by plugging 4 in for x. So f of 4 is equal to 2 times 4, which is 8 plus 4. So f of 4 equals 12. What this tells me is that at 4, when x is 4, y is 12. So that is the ordered pair that I get. Let's go ahead and take a look at another example. So we're going to determine whether you have the x value or y value to replace. And I'm trying to find g of -2, which means I'm replacing all of the x's with -2. I'm going to go ahead and substitute that in. So g of -2 equals -3 times -2 minus 5. So remember, I'm substituting in what x is equal to for every x. So g of -2 equals negative times the negative gives me a positive 6 minus 5. So g of -2 equals 1. What this tells me is when x equals -2, y is 1. That is my ordered pair. All right, so let's go ahead and look at a different example of this. It's actually telling me to find x. So this time, instead of telling me what x is, they tell me what f of x is equal to, which means I'm going to be taking this f of x and plugging it in where you see f of x. So this one's a little bit backwards. So I'm going to plug -4 in for f of x, and I'm solving for x. So now I can follow those steps, that order of operations, and solve. So I'm going to subtract 8 from both sides, and then divide. So -2 equals x. So my x value is -2. So what this tells me is if I were to plug -2 in, I should get -4. So let's check our work. If I plugged -2 in, if it was f of -2, 6 times -2 would be -12 plus 8. So f of -2 should equal -4. Well, that's true. That's what I found out. So with these functions sometimes, it is beneficial to check your work. All right, so let's go ahead and I want you to pause here and try each one of these. Try each one of these, and when we come back, I'm going to work through each example. All right, welcome back. So you should have been trying it out on your own. Let's go ahead and work these step by step. So for the first one, we should have plugged in -3 for x. So f of -3 equals 2 times -3 plus 10. So f of -3 equals -6 plus 10. So f of -3 is equivalent to 4. So my ordered pair would have been -3, 4. Number 2, find f of 4 when f of x is equal to -4 times x plus 7. So in this case, I'm going to be plugging in the 4 for x. So f of 4 equals -4 times 4 plus 7. So -4 times a positive 4 is -16 plus 7. So f of 4 is equivalent to -9. So my ordered pair would have been 4, -9. All right, and last one. This says find f of x when f of x is equal to 5x minus 2 and x equals 8. So in this case, I'm going to be plugging in and solving for f of x. So f of x, or f of 8, equals 5 times 8 minus 2. So f of 8 equals 40 minus 2, which is equal to 38. 38. So my ordered pair would have been 8, 38. All right, if you missed one of these, I encourage you to go back and try them again. And just make sure that we are very clear on how to do this. All right, so how we solve for a table. So sometimes you'll be given a table and asked to fill in the f of x column. It's that same thing we just did. We're going to use each of the x values. So I'm going to use f of 1, plug that in for x, and solve for that f of x. So f of 1 equals 5 minus 6. So f of 1 is equal to -1. I'm going to go ahead and switch colors here. So f of 2 is equal to 5 times 2 minus 6. Remember, I'm just plugging it in to that equation. So 10 minus 6. So f of 2 is 4. And the last one here, I'm going to plug 3 in. So f of 3 equals 5 times 3 minus 6. So f of 3 equals 15 minus 6, or f of 3 is equal to 9. I want you to pause here, go ahead and plug these in and solve. All right, so these here should be working backwards. This time they're giving me f of x. So f of, oh, let me go ahead and erase here. I should be how to go ahead and erase my board. Is say that -8 is equal to -x minus 5. Remember, we're going to be solving. We're solving for x. So -3 equals -x. We need to divide both sides by -1. So 3 is equal to x for that first box. For that second box, it's telling me f of x equals -1. So I'm going to be solving for that x again. So -1 plus 5 is 4 equals -x. Divide both sides by that -1, so x equals -4. And the very last one, when f of x is 2. So this time 2 equals -x minus 5. I add that 5 to both sides. Hopefully we've gotten very good at solving equations. So there we go. All right, so we're going to take a look at evaluating functions with graphs. All you're doing here is when they say f of 2, they're saying, okay, when x equals 2, so when x is 2, where is y at? That y value is 4. You're going to do the same thing. So f of -2, that y value is -4. At 0, I'm at 0. And at 1, I'm still at 0. So there you have it. I want you to go ahead and pause and try this one on your own. All right, so when x is 0, y is 2. When x is 5, y is -3. When x is -4, y is 6. And when x is -2, y is 4. All right, again, go ahead and pause and try this one on your own, and then we'll wrap this up.